Now we're going to take a look at what's called the ambiguous case. Some of you, I think, have may have referred to it as the donkey case or something of that nature. Um, it's the situation where we have two sides and an angle, and so we have side angle. Let's take a look. It's probably easiest to illustrate by looking at an example. Suppose we have side B is 34, side C is 53, and angle B is 32. So if I see that here, sketch the model triangle, and once again, I labeled in red the items that I don't know, and I set up the ratios based upon what I have. So what I have here is sine of A over A, I don't know either of those, equals sine of 32 degrees over 34, there's my match set, equals sine of angle C over 53. So now, since that's the second ratio, is the one that's known, I'm going to use that, and I'm going to solve for the sine C, because again, that's the fraction where I just know one item and I don't know the other. So I have sine 32 over 34 is sine C over 53. And if I cross multiply, I end up with 34 sine C is 53 sine 32, or in other words, sine C is 53 sine 32 divided by 34. Do the math out, I get approximately 0.826, and I do the inverse sine, which will give me 55.7 degrees. Using this, I can then find angle A, because now I know two angles, using my 180 degree angle rule, and I learn that angle A is 92.3 degrees. Now that I know that, I can go back and find side A. So when I do that, I have sine of 32 over 34, again, go back to the information they originally gave me, equals sine of 92.3 divided by A, and if I cross multiply, I end up getting 34 multiplied by sine 92.3 degrees equals A times the sine of 32 degrees, and when I solve, I get A is 64.11. Now, in this example, there's actually a second answer. In fact, when we use the law of sines in the side angle case, we must always check for the second solution. So in other words, if I know two sides at an angle, and I'm using the law of sines, particularly the side angle, I want to check for a second solution. So if I do that, I go back to the very beginning when I first solved for sine C, and I learned that I had an angle of 55.7. What hopefully we remember is that there's another angle whose sine would be that 0.826 number in the second quadrant. And so using what we've done in the past, we go and we say, okay, if I use, remember we talked about reference angle. If I use an angle in the second quadrant of 55.7 degrees relative to the x-axis, I would learn that this other angle, this second quadrant angle, is 124.3. So now my second triangle is going to have one very, very large angle. And let me just double check that I do in fact that is legal to have. So notice if I've taken that second angle that I found in the second quadrant, and I now apply that 180 degree rule. Remember, my first angle was 32, and now if I do this 124.3, notice the math works and I actually get 23.7. That's how I know I have a second triangle. If I go and I move that first angle I find into the second quadrant, and then I can still apply the 180 degree rule using the first angle they ever gave me and this second quadrant angle. If I still get a positive third angle, then I know I have a second triangle. It's a little bit tricky, a little hard to explain. Now I'll use that to find side A. So again, go back to what I knew. Sine 32 over 34 is sine of my new angle, 23.7 over A. Cross multiply, I get 34 sine 23.7 is A times the sine of 32, and I learn that A is 25.79. And so now what you'll see is I get two answers. And so what I've done is I've written down the answers that I just managed to get, and then followed by the answers that I had the first time that I did the problem, the first half. This is a very, very tricky question. You really will want to spend some time going through it and convincing yourself that you know how to get the second triangle.